So in the directions, they want us to make a substitution and then integration by parts. Now, remember that integration by parts, they really always use the same letters. They use U and V. So I'm not going to use U and V when I do the substitution. I want to pick a different letter. So when I do the substitution, I'm going to use the letter W. So that after that, when I'm ready for parts, I'm going to use different letters, U and V. So let's try this problem right here, which looks a lot like the one from the assignment. So let's see here. First, we have to make a substitution. I'm going to use W. I am going to let W equal. Now, let's make this selection wisely. What from here am I going to allow to be W? I'm going to allow the function within the function. In this case, this entire exponent, that is going to play the role of W. And so now what I want is, I want to rewrite all of this in terms of W, no x's. So in order to do that, we're going to have to find the derivative of W. So remember that if I write this a little differently, the square root of x is the same as x to the 1/2 power. Now the derivative dw would be, well, take the derivative of this. That'll be 1/2 x minus 1 to the negative 1/2 times dx. So dw is the same as, if I clean this up, that'll be dx over 2 square root of x minus 1, and just put the 2 on the bottom. Negative 1/2 is the same as 1 over the square root. Now I want dx alone, so I'm going to multiply both sides by 2 square root x minus 1. 2 square root x minus 1. That knocks this out. I want dx alone. So now here I have 2 square root x minus 1 dw equals dx. But that can be replaced by w, right? Square root x minus 1 is w. So this is 2w dw equals dx. So now what we're ready to do is we're ready to go back here and rewrite all of this in terms of w's. So the 7 can actually be kicked out to the front. It's a constant. Now I have e. Now my exponent should say square root x minus 1, but square root x minus 1 is w times. Now I'm supposed to put dx here, but what does dx equal? Dx equals that there. So I have a 2 times w times dw. So 2 times w times dw. And that's exactly why it was important to get dx alone, which is why we did this whole clear out the denominator. And then over here, we turned that into w's, because on one side you want x's, and on the other side you want w's. So that when that dx disappears there, it turns it into stuff with only w's. So let's clean this up. The 2 can go outside to meet the 7 to become 14. We can clean things up a little bit. So we've done the first part where we use a substitution. So instead of x's, we have only w's, like w, w, w. Now is the time to make our parts. We need integration by parts. Now, when I do integration by parts, I've set this up the same way for like 1,000 years and it always works. Here's what I do. I always go u, du, v, dv. This is the exact setup that I've used since I was in high school. So now we're ready for the integration by parts, where the stuff in here has to be ripped apart and placed in for here and here accordingly. Now the dw is always going to be part of the dv, so I'll just put that in the back. It's just a question of these two pieces. That's a function and that's a function. Which of these two is going to go for u and which one is going to go in for dv? That is always the decision that we have to make. One of these pieces goes in for u and the other piece goes in for dv. Always, always, always. Now here is how I would make that decision. We have w versus e to the w, okay? Now, let's consider derivatives. The derivative of w would be like 1 dw. And then the derivative of 1 would be 0. So it sort of dies, right? Now, what about the derivative of e to the w? The derivative of e to the w is e to the w. But then the derivative of e to the w is itself. It just goes back and forth all day. So sometimes one of the functions expires or dies out, and the other one just goes back and forth all day. So the one that sort of dies out, in this case w, definitely allow that function to play the role of u. So we have w is going to go in for u. And then whatever is left would go in for dv. And these problems are designed to work. So if this is u, then du would be dw. And if this is dv, then its antiderivative would be v. Well, what's the antiderivative of e to the w? Well, it's self, because the derivative of v is dv, and the derivative of that is that. So that's how we take a function and rip it apart into these particular assignments, which is called integration by parts. So now let's actually apply what this is. So here's what we're saying. So this is going to equal, I should have had equals all along, equals. 14 just collapses. Now, this stuff here, that is going to get ripped apart according to integration by parts. Now, let me show you how this works. So we have parentheses, and then it's always going to be u times v. Well, here's my u and here's my v. So u times v would go right here first. Minus, because it's minus, and then integral. And then in the integral, I go v du. That's v and that's du. So those guys side by side go in here. So I have e to the w times dw. So you can pretty much forget everything above, because now this here is what we're currently focused on. And that equals the original anyways. So now let's just focus here. So we have, let's see, so we have 14, that stays. Well, how about this part there? So we have 14 w times e to the w minus, what's the integral of e to the w? Well, just itself, e to the w. And then we can close that. And so we have applied our substitution. That was the first thing we did. And then we just completed integration by parts. We did all this here, we're done with that. So now all that's left is to rewrite this problem in terms of the original variable. The original variable was x. So let's go back in terms of x's. So we have 14, parentheses. Now instead of w, what did w equal originally? W equaled that, square root x minus 1 times, and then we have e to the power of w, but w is square root x minus 1, minus e to the power of w, which is square root x minus 1. And then I suppose you can just put a plus c, a constant. And if you want, you can clean this up a little bit. I suppose you can factor out e to the power of square root x minus 1. And then left inside, you would have square root x minus 1 plus c. Because there was a 1 right here that was invisible. So when I took out e to the square root x minus 1 to the front, I was left just with this piece here and the negative 1, which is right there. So let me write this a little bit nicer. And so now what you can do is you can mimic your particular exercise, which behaves a lot like what has been shown here. Okay, there it is. So that would be what I submit to my professor.